Alrighty. Number 13. What is A? 4. What is B? 1. Hey, tricky question. What is H? Nice. K is 0. Okay. When K is 0, I do not graph the midline because it's already bold. So just going to go to the amplitude then. Okay. All right, so on this particular problem, we're gonna have to eyeball the locator point a little bit. Pi over 4, positive pi over 4 is located right here in between 0 and pi over 2. So you're gonna have to eyeball one box back. I think, to be honest, it's probably right where the lines end. So just imagine that there's a vertical line down here. Okay, period is 2 pi, which is 1, 2, 3, 4, 5, 6, 7, 8 boxes. One, 2, 3, 4, 5, 6, 7, 8. Yep, positive sign looks like this. So I like to put the middle dot in first. 1, 2, 3, 4. And then the first dot, and then the third dot. I don't believe I gave anyone permission to move their seats today. I don't remember being asked permission. Assumptions. Okay, now move down to number 16. I know it's weird that I skipped 14 and 15, but our notes today start with this, so I didn't want to do it as a warm-up. We've gone over this somewhat. Okay, sigma notation, term 0, term 1. So we're going to need 2 sigmas. Sorry, they're not perfect. You'll be fine. Okay. Growth on this is 2, it looks like. Term 0 is 601. Which letter do you want to use? Typically, as you can tell, it's N, K, M, T. I like to use N. I'm going to use N every time because it says number to me. I don't know. I guess I don't know why I asked you if I was just going to use N in the first place. Okay, so here's my first one. This is in terms of term zero. I told it to start at 1, end at 7. And my equation is 2n plus 601. And then for the first term, 2n minus 1 plus 603. Okay, anything that's kind of new? Anything you want to ask about that one? You see where all the stuff came from? Okay, now if you could look at the weekend homework, which was the quiz review. I know you didn't finish it. I told you you didn't have to. I just want to ask if there are any burning questions about it, except, do not ask me about 12, 13, and 14 yet. Are there any burning questions about any problems other than 12, 13, and 14? Maybe there were until we did that warm up and now it makes more sense. Yes, honey. Okay. Oh, I think I'm gonna try to guess what your so let's see. We found the formula for this on Friday, I believe. So first term times r to the n minus first term over r minus 1. And I'm wondering if you are wondering what the first term is because there's nothing there and it's 1. So you put a 1 times in the front of that guy. And the first term is 1. Multiplier is 3. Number of terms is 10. And then I'm sure you got it from there. Just be careful with the calculator. I do want to say a couple of things. On the quiz, calculator will be allowed. Please don't ask me 50 million times if you can use your calculator on the quiz. Yes, the answer is yes, 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 you can use your calculator on the quiz, yes. Also, in the post for the topics, it says that we will be giving you the 2 formulas. So, on the top of the quiz, there are like little boxes like last time, and this one are both in there. But you need to know that one's for arithmetic. I mean, you need to know what is arithmetic and what is geometric. But you do not need to memorize these two. Does that make sense? Anyone? Anyone? No? Okay. All right. There's not supposed to be a bullet here. Sorry. My bad. So we're going to do three things today. The first is note on geometric stuff. Then we're going to do number 94, which is kind of a mixed review. But it's going to give you some arithmetic, some geometrics to figure out what to do. The last one in that one is really spicy. We're going to do that one together for sure. It's the first time we actually have to log stuff in this chapter. And then number 95 is one of those where you have to find the number of terms, which is like the one with the quick review that I said to ignore, which you guys already probably figured out. Did you do really spicy diamond boxes or did you just go plot one? I always do plot one. Because we're diamond boxes. Not, I mean, anyway. They're possible. They have to be possible because they have to come out to one number. But too spicy. What? Why are you laughing, Vicky? Other than the fact that I'm tripping over Steve. I mean, sometimes I deserve it. Yes, yeah. 8, 16, 32 plus dot 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 to 16 terms. Did it look like that was like numbers? Oh, no, that's all right. Okay, here we go. Geometric sequences are number patterns formed by repeated multiplication of a common ratio R. So R is the multiplier. You guys can call it the multiplier. Totally fine. Over here, because these are notes, I want to include that little formula to find R because sometimes with geometrics, it's hard to just eyeball what the multiplier is. Clearly not in the example I picked. That one's not too bad. What a crazy multiplier you picked, Mrs. Thomas. Okay, and then the last thing is they're separated by commas. And this is my hope that you guys will see the difference between a sequence and a series. So sequence is comma, series is adding. Okay, I've given you a sequence. And we are going to find two things. We're going to find the multiplier and term 0. I'm going to use my pink pen. Multiplier is times 2. Term 0 would be 4. And we're going to write the equation in two ways. We're going to write it in terms of term zero and the first term. And I'm going to give you the formulas for those in case you need them. Okay, so in this particular example, term zero is 4, multiplier is 2. And term 1 is 8, and multiplier is 2. You have any questions, anybody, about how to find the equation in terms of term zero or in terms of term one? Any questions at all? You're gonna have the same exact example, but now I put pluses in between. Woo! The definition of a geometric series is the sum of a geometric sequence. So the commas have changed to pluses. And we derived the formula for that on Friday. It was super fun. I had a great time. Okay, and when I find the sum of a geometric, over on the side, I like to state what the three things are that I need to find the sum. First term, multiplier, number of terms. First term in this problem is 8. Multiplier is 2. And over here it gives you n. It says add to 16 terms. Somebody like me was too lazy to write out all 16 numbers, so they just put that. It's like I've been here before. Okay, now at this moment, I would like you all to get a calculator out. Everyone, all of you, every single one, and get the answer for this properly. Because muscle memory is a thing, and I'm not going to help you with a calculator on the test or quiz. We all need to know how to type this in. Doesn't matter. It only matters if you're going to hit the sine or cosine button, and you're not going to hit that in any of these. Okay, make sure that you're doing it correctly. Type until you get the proper answer. This is not one where you can type in into one fell swoop. By the way, if you like comedy, you should look up Nate or Bargatze's bit on one fell swoop. Apparently his wife uses one fell swoop inappropriately and he gets really mad. They get in a fight about it. It's hilarious. There are times for one fell swoop. This is not it. Yep, yep, yep. No one else can understand the fact about it. One fell swoop, he did it, one fell swoop. Even though I said not to do it in one fell swoop, he did it in one fell swoop. I'm totally just leaving him to say one fell swoop a bunch of times. In one fell swoop. Yeah. Not at all pertinent to the lesson or anything. It's just gonna teach you all in one fell swoop about the words one fell swoop. Okay, so summation notation, last thing. Make your sigma. And you can put either of the two equations next to it. You're going to see the geometric ones written in terms of the first term like 90% of the time. So I'm going to do that because that's what we're going to be used to seeing. You can put the other one if you like that guy better. Doesn't matter. Totally fine either way. N equals 1, and then it tells you to stop at 16. And then what I'd like you to do is put equals 524,280. So you can make the connection that this is saying the same thing as that with an answer. Up for you, Theo. You know how I moved it? In one fell swoop. How can you put up number 94? If you not, won't be in it. I don't. One fell, that's really one fell swoop. Okay. The calculator's got cheat codes. Okay, so moving on. Okay, what I'd like you to do is write these four down. This one goes to E, by the way, but just starting with these four. Yes, one plus three. Yes. Okay, you guys, so when you're done writing these down, what I'd like you to do is in your groups that actually have people, I want you to discuss whether or not these are arithmetic or geometric, and I want you to put a little A or a little G somewhere in the problem. So just take a look at these four, go through them, arithmetic or geometric. I've given you some mixed business here. Okay, let's go over them. A is geometric. You can tell because it has an exponent, so it's the T power. B is arithmetic. You can tell because there's no exponent. Also, you can sort of tell it's like if you distribute it, you can get to mx plus b form. But the fact that there's no exponent makes it arithmetic. This guy is adding 4 each time, correct?
Yeah.
So arithmetic. And that guy is also arithmetic because it's 11q plus 0, which is mx plus b. Okay, so basically exponent, no exponent, no exponent, no exponent. So geometric, arithmetic, arithmetic, arithmetic. Okay, now geometric, you guys know the formula. Well, maybe it should be on your paper from a minute ago. By the way, these are all find the sum problems. So we're finding the sum. What 3 things do you need for a geometric? Term 1, ratio, number of terms. Okay, so over here, right, T1 equals R equals N equals. Now this one is spicy. It's spicy because of the bottom. You notice that it doesn't start at 1. And to be honest with you, in math, sometimes it makes a lot more sense to start at 0. We're not going to do it very often in this class. Mostly that's like pre-calc and calculus stuff. But once in a great while, we'll throw it in there. Okay, now, how do you get term 1 from an equation? Plug in 1. Okay, so everyone plug in 1 into 5 times 2 to the t, which would be 10. So you might want to write 5 times 2 to the 1 equals 10, just so you can see what happened. Okay, what's the multiplier? That's easy. 2. Okay, now this one's not easy. Think about it. How many terms are there between 0 and 15? 16. Because you got to include the 0. Okay, so you should have 10 to 16. Now do the formula. Just like we did a minute ago, you go to the calculator, make sure you get the correct answer. That's it. Great timing, sure, whatever, it's fine. Great time to miss, awesome. Fine, whatever you want. Sure, whatever, great.
Or should I do it after like all four problems?
I don't know, probably whatever you want to do is fine. Okay, if you're using the one fell swoop method, make sure you use parentheses properly. Final answer should be 655,350. Matthew, did you do it in one fell swoop? Well, you did kind of do it in one fell swoop. It's not one fell swoop. This is not at all me trying to say one fell swoop a million times in the middle of a lecture. Okay, now, this one's arithmetic, we decided, right? What do we need for arithmetic stuff? Yep, number of terms, great. First term and last term, which in this case, can you guys all see is going to be term number 179. Okay, so there are 179 terms, no need to overthink. We started at 1. How do I get the first term when I have the equation? Plug in 1. How do I get the last term or the 179th term when I have the equation? Okay, go for it. And then do the Gauss formula. You got this. Yep. Honey, what's 1 minus 1? What's 0 times -4? What's 16 minus 0? To be honest with you, I just typed it in the calculator. I got negative 60,860. No? Yes? Okay, I want you guys to skip C for a second. Go on to D, same exact thing as B. Give that one a go. That further that uses Q. Mhm. All right, it's a Q. A Q. It's not 119, it's a Q. It looks like a 119, but it is a Q. Yeah. So, okay, wait, Connor, so how many terms are there? Okay. He can do it. I can't do this. Mm-hmm. Do you guys have that situation under control, or do you need a house call? I got 537,108. Did anyone else get 537,108? Okay, good. Early in the morning, I have to second guess myself. Okay, so now we're heading into three spicy problems. Three spicy meatballs. Yes, so we have to do number 95, which is not appearing on the screen yet. She's down for it. Okay, why is she out? Okay, so we're gonna do C. We decided this was arithmetic, correct? Okay, so sum needs three things, N, T1, T of N. So you see the problem's already occurring. So N we don't know. T1 is 4. T of whatever we know is going to be 392, but the whole problem is we don't know what spot it's in. Okay, so what do we do when we're stuck? We go to the equation. Now, in this one's easy. So I'm going to do it in terms of term 0. So this is going up 4 each time. And term 0 is 0. That's fun. Okay, so 392 is 4 times how many spots plus 0? 392 is 4 times how many spots? Oh man, I have left 0 room to find the sum. That's cool. Okay. Now if you guys could write down E and just notice its foreboding. When you're writing down E, you should play some kind of like scary music in your mind. You know, like that sort of scary music. Because it's got, spicy fracciones in it. Okay, E. It's an eight. Why am I struggling with this? Okay, here we go. Okay, can anyone tell me what the multiplier is here? 1/2. Okay, and I can tell if I just look at these two because the top is staying the same, so it's multiplying by 1, and the bottom is multiplying by 2. So top staying the same times 2, so we know the multiplier is 1/2. Now this one is geometric. Geometric needs 3 things. It needs the first term, R, and N, and R we decided was 1/2. Now, what did I tell you guys to do if you could not figure out R on your own, like just by looking at it? We put it in the notes a minute ago at the start. Mm, term 2 divided by term 1. Term 2 is 2.5 as a decimal. Divided by 5 is 0.5. And I'm changing this to a fraction because this is in a fraction. And anyway. Okay. First term is 5. How many terms are there? Wait. Okay. So this should give you kind of the feeling of this. What do you do when you don't know something, when you're stuck? You go to the equation. Okay. And this one, I'm too late. Actually, I'm not too lazy to find the first 0th term. 0 term is easy. So T of n equals 10 times 1/2 to the n minus 1. Are there any questions about how I got the equation? Oh, why aren't you guys fixing me? Thanks, Theo. You fixed me. Now, could I have done this with the n minus 1? Yes, I could have just left that a 5. But I'm going to log this, so I want the exponent to be as easy as possible. Okay, anyway, I'm going to plug in the 10 over 4,096 because I want to find out what term that is. We'll see. Tens canceled, in case you're wondering. I did keep change flip. Okay. Pull out of the tree, bring the N in front. You should get whole number positive answers for these. It's kind of like how you know you did it right if you get a whole number positive answer because it's a number of terms, so it has to be the spot that it's in. Okay, now this one came out to weird answer. It's not that uncommon, but I do want you to just take note of how weird this answer is. We're going to come back to this problem tomorrow because that weird answer is actually a thing. It's super close to 10 is what I'm trying to tell you. And that is the next thing we're working on. And it's called convergence and divergence of infinite series, which sounds really fancy, but it's not hard at all. I just like to say the words because it makes me sound smart. Okay, last problem, number 95. And this is the one that is like number 12, 13, and 14 on your quiz review. Okay, so the first thing you do on all of these problems when you're finding the number of terms is you decide if it's arithmetic or geometric, and you write down the sum formula. Can you guys tell from the T of n equation that it's arithmetic because it's mx plus b? So that means I chose the arithmetic sum formula. Okay, and now I'm just going to plug things in. So the sum, this big S stands for sum, by the way, 3429 equals n over 2 first term plus last term. Okay, now I'm going to do the simplification of this first. Then I like to multiply both sides by 2 to get rid of the denominator because these are odd numbers. I don't want to have fractions or decimals. Hey guys, so close. So this is diamond and boxable every single time, but I don't want to do it because it's too spicy for me. I'm gonna go quad formula every single time on these. On your quiz, by the way, quad formula is printed at the top, so you do not need to memorize it. Hmm. Okay, and it's really important for me to tell you, 1 second, this should come out perfectly. If it does not come out perfectly, you did it wrong. And I also need to tell you, very last thing, you don't have to do the minus, you only have to do the plus because it has to come out positive. Done. So these will always come out to be positive full numbers every single time. Positive full numbers. And I promise you tomorrow is much shorter. I don't even know why I took so long. Maybe I went too slow.
Yeah.
Nah, I think it's just the morning.